Welcome back to differential calculus class. So we are still on rules of differentiation. So in this class, I'll be showing you rule of exponential function for other bases other than natural base. So in our previous class, we discussed the rule of natural exponential function. So here we're talking about other bases apart from natural exponential function. So let's say we have given f of x equals, so instead of e, which is natural exponential, we are going to have other base. Let's say a raised to power u is a function a raised to power a particular function. So if we have this and we are asked to find the derivative of this function, the derivative of this function is simply f of this, the f prime of x, that is the derivative of the function, will be equal to, we differentiate the original function, we differentiate the power here. So we have u prime, we have x, then multiply by the original function a u x, then we are going to have multiply by ln a. Okay, now let's apply this. Let's take a look at some examples. Let's say we are asked to find the derivative of, so let's say the first one here, let's say we have y equals to a raised to power 2x, question 2 here we have f of x equals, this way we have 2 raised to power what? 1 minus x. So it's a 1 minus x. Sorry, 2 raised to power 1 minus 2x. So if you are asked to find the derivative of this, so applying this rule of exponential function, how are we going to do that? So you just need to study this. So solution is very simple. So for the first one, we have y equals a 2x. So in other words, here the y, the x, will be equals to, don't forget, we differentiate the power. Differentiate the power because this is the power, this is equivalent to the power, and this is it. Okay, meaning that the u of x is equals to 2x. So we differentiate the power. So when we differentiate this power, we are going to have, because this power is a linear function, differentiation of 2x is equal to 2. Then we multiply by the original function. What the original function? The original function is a raised to power 2x. Then we have ln of the exponent, ln a. Okay, then this is equivalent to what? To a raised to power 2x ln a. This is our answer. So for the second one, we have f of x equals 2 raised to power 1 minus 2x. If we have to find the derivative of this, which is f prime of x, will be equals to, we differentiate the power. The power is 1 minus 2x. So this is a constant, this constant becomes 0. Then we have 2x. So this is a linear function. So minus 2x is a linear function. So when I differentiate minus 2x, don't forget the sign will still be there, minus. Then we have 2x, which is a linear function. Dimension of the linear function is the coefficient of the relevant variable, which is 2 here. We have 2. Okay, then multiply by the original function, which is 2 raised to the power 1 minus 2x. Then we have multiplied by ln 2. So in other words, we have minus 2. We have minus 2. Okay, ln 2. If you like, then into bracket 2 1 minus answer here. So, can you try this? Try this. Try this. So, if you have this function, let's say we have 1, y equals, let's say we have 4 raised to power x plus 2. We are asked to differentiate this. So, we have y equals 5 raised to power x squared. Can we differentiate that? So, drop your answer in the comment section.